All right, Logic fans, welcome back to our third and final video on section 5.2, which is our introduction to Tableau techniques, and I'm just giving you lots of examples. So I want to continue on our study of Tableau techniques with respect to the categorical A, E, I, and O sentences. We left off having finished the E categorical sentence, so let's practice the I and the O, which gives us some practice with the existential quantifier, and go ahead now and in three objects provide me with an interpretation that makes the categorical I statement true, and in three objects an interpretation, Tableau interpretation, that makes the categorical I statement false. Pause now. Okay, hopefully you've had a chance to do it, but yeah, the first thing you want to do is set up, okay, I asked for three objects, or your professor asked for three objects, so you're going to use three, and you've got F and G as your property constants. There's no individual constants, so we don't have to make sure that the individual constants are appearing here. We're fine with these three. For the true interpretation, this says at least one thing in our domain, right? Fish around in Santa's bag, there's at least one thing in there, either this thing, or this thing, that satisfies this description. It's both F and G. So, let's pick the object B, and as long as you have this, you could have A that way, you could have C that way, you could have some combination of them that way, but you have to have at least one, because it's the existential quantifier. At least one thing satisfies this description. So fill in the rest however you like. This is an interpretation that will make the categorical I sentence true. Now, for making the categorical I sentence false, right, it can't be the case that there's anything in there that is both F and G, right? So if we go, something like this, for example, right, as long as everything in there lacks at least one of these two properties, then nothing in there is both F and G, okay? And so there's other solutions, but this would be a solution. Fill in the rest here however you like, and it will be an interpretation according to which the categorical I sentence is false. Okay? All right, go ahead and try the same thing with the categorical O sentence, an interpretation in three objects that makes it true, and an interpretation in three objects that makes it false. Pause now. All right, hopefully you've had a chance. Let's go ahead and try this together. So let's see here. I need at least one thing to make it true that it has F and lacks G. So I don't know if this is like this, then fill in the rest however you like, and you're going to have an interpretation according to which the categorical O sentence is true. Right? There's at least one thing in Santa's bag that satisfies this description. It's F and it's not G. C is that way. Okay, so that's really nice, right? Okay, let's try a case that makes the categorical O sentence false. All right, how would we do that? Well, it can't be the case that there's anything that both has F and lacks G. So one really simple way to do that would be like this. Okay, is there at least one thing in there that's both F and lacks G? No, because everything lacks F. So that would be one simple way of doing it. There's other ways and more sophisticated ways, but that absolutely suffices to solve this particular problem. Okay, let's try a couple more examples. Really, I just want you to see lots and lots of examples. I think it's the best way to learn this. Okay, I'll try to give you maybe some harder ones. Keep in mind that the textbook has plenty of examples and solutions, and we ramp up in complexity. We start with easier sentences, then we build into more difficult ones. Don't worry about relations. We have a separate section of the textbook where we talk about how to do Tableau interpretations with sentences involving relations and identity, and that's all separated into separate sections, okay? Okay, so let's try to ramp up our complexity a little bit and look at some harder cases. So again, we're going to use three objects for all of these, but can you provide me with an interpretation of sentence 1 here that makes it true, and an interpretation, Tableau interpretation, that makes sentence 1 false, again, in three objects? Pause now. Okay, hopefully you had a chance, but this is a conjunction. So both conjuncts have to be true, right? And notice I've got F and I've got G represented here. Okay, never put a negative up here, right? You're always going to represent it positively, and then you do the plus or the minus accordingly in the box. Okay, so everything has to be F. Okay, simple enough. A, B, and C both have the property F. So everything in there is red, and there's at least one thing in Santa's box or Santa's bag that lacks the property G. Okay, boom. Fill the others in however you want. That's an interpretation that makes sentence 1 true. To make sentence 1 false, right, we need to make at least one of the disjuncts false. Okay, so the simplest thing might be, or at least one of the conjuncts false. Maybe if I just did that, right? So that, this conjunct says everything is F, but that's not going to be true. So by a false left conjunct, the entire conjunction is false, right? Okay, and there's other possible solutions. Okay. Go ahead and try number 2. Can you provide me with an interpretation in 3 objects, a Tableaux interpretation that makes sentence 2 true and one that makes it false? Pause now. Okay, this one can be a bit harder, right? But you have different options. Either you can make both the left and the right sides true, or you can make both the left and the right sides false by the truth table for material biconditional, right? So if we're going to do an interpretation that makes it true, let's say we wanted to make both sides true, just as an example, okay? And what we're going to have to do here is we're going to have to add a third column, right? So we're going to have to add a column for the H, sorry, the column for the H, and you can use a Y up here too, it won't matter, okay? So if it makes you feel better, we can do that, but if we make both sides true, okay, so we need at least one thing that lacks the property G. So now the left side here is true. And then we need to make sure, since this is true, that this sentence comes out true as well. So we need everything to have F and lack H. So everything's going to have F and everything's going to lack H. And there's an interpretation according to which sentence 2 is true. Okay? To make it sentence 2 false, what we have to do is we have to make the left and the right sides take opposing values. So for example, we could make the left side true and the right side false, or vice versa, the right side true and the left side false. Okay, so what we're going to do there is we're going to ensure that, let's find an easy way to do it. Maybe what we'll do is we'll make the left side true, because that seems to be a pretty easy thing to do. So we'll put the minus there, okay, and now the left side is true. So now we got to make sure that the right side is false. The right side says everything satisfies this description. So if we just do that, right, then it's not the case that everything is both F and not H, right? So this would suffice to make the left part here true, the right part here false, and therefore the biconditional false, okay? So it really behooves you to really know those truth tables, okay? I'm just doing rapid application of it, and by this point in your study, your professor is really going to expect you to have mastered those by now. So if you didn't get them down before, you got to stop everything you're doing and get them down now, because we don't want you to not like logic. We want you to like it, and it's going to be murder for you if you don't know your truth tables, okay? All right, moving right along, can you provide me with an interpretation? Oops, I left something out here for number 3. We'll make it a disjunction. Can you provide me with an interpretation that makes it true in 3 objects and an interpretation that makes it false in 3 objects? Pause now and see if you can do that. Notice you do have the individual constant B. Okay, so in order to make this sentence true, right, we've got the individual constant B, but luckily we've already got B represented here. Okay, so we're good to go on that. In this case, we do not need this column. We do not need, there's no H property constant that appears. But in this case, notice it is true that F appears in 2 places. So, what you do to B here is going to sort of determine what you can do to B here, okay? So you can't just sort of like put, plus and minus in each case. B either has a plus or a minus, and it doesn't have both, okay? All right, so let's take a look at this. If we're going to make it true, I suppose the easiest thing to do would just be to make B lack the property F. Then you would have a false antecedent, and you wouldn't even have to think about the consequent, okay? But let's suppose you made the antecedent true. Now you would be required, in order to make the conditional true, you'd be required by the truth table for conditional to make the consequent true. So that would mean we need at least one thing that's either F or lacks G, or that lacks G or has the property F. But notice you've already got it. Kind of cool, right? That should suggest something to you about this sentence, right? So once again, if you make B have the property F, you've already got this part being true because you've got at least one thing that's either lacking G or has F, namely B. Okay, so that should suggest something really, really cool to you, which is basically that in this particular case, you cannot provide an interpretation that makes it false. All right, that's because it's a tautology. All right, this is actually a tautology, something where you won't be able to prove that until we get to chapter 6. Okay, but yeah, whether you make this true or you make it false, the entire conditional turns out to be true. Therefore, there's no way to make it false. Okay, so that's kind of an interesting, nifty sort of case to think about there. All right, last one, I promise. Let's do this guy where we've got a leading negation situation and see if you can figure it out. Can you provide me with an interpretation that makes this sentence true in 3 objects and an interpretation that makes it false in 3 objects? Go ahead and pause now. Okay, in order to make it true that nothing has the property G, that's another way of rendering this, right? It's not the case that at least one thing has G. It's like saying nothing has G. We have to make sure that everything lacks it. Because provided at least one thing has it, imagine it like this, right? Then that sentence is going to turn out to be true, but we want to make that sentence false. In other words, we want to make that sentence true, right? So it's going to have to work like this. Okay, nothing has the property G. Okay, so that's going to look like that. And that's the only way in 3 objects to make that sentence true. Okay, in order to make it false, any other option would suffice. So this says nothing is G. So provided you have at least one thing that is G, doesn't matter which one, this sentence is going to turn out to be false. It's going to be false that nothing is G. At least one thing is, right? Okay, I hope you appreciate how much simpler this can make your life from what we were doing in 5.1. And again, we're going to use the notion of interpretations to define all of our important semantical concepts, including, for example, the notion of a tautology later. And when we do those definitions, we're going to be taking for granted the Tableaux techniques and that sort of streamlined way of presenting interpretations. So be sure you're doing the practice problems, right? You're getting a lot of familiarity with difficult cases like these, and we'll see you on the next video, 5.3.